In this video, we will see why we always need to observe degree of freedom when working with sample statistics, like the standard deviation and variance. So why do we need to observe degree of freedom in working with sample statistics? Take note, a statistic or a sample statistic is the equivalent to a parameter for a population. So if we have a population mean for a parameter, then we have a sample mean for a statistic. Let's look at variance and standard deviation based from the sample here. Okay? These are both, again, sample variance and sample standard deviation based on the letter that you see here. Okay? Notice how the denominators of these equations, okay, have the expression n minus 1. Okay? That n minus 1 or number of samples minus 1 is actually the degree of freedom. But here's the question. Why do we need to subtract 1 from our number of samples when we solve for the sample variance and sample standard deviation? Well, this is because the degree of freedom observed in solving a sample statistic, like the variance, sample variance, and sample standard deviation, is always 1 less than the number of samples, n. Okay? So meaning to say, if you did sampling and you had 30 samples, your degree of freedom will be 30 minus 1 or 29. But the question is, why do we need to do that? What is the degree of freedom? The degree of freedom is the number of values in the final calculation of a sample statistic that are free to vary. We only consider those values that are free to vary or are governed by chance to avoid bias in the final result of our sample variance and sample standard deviation calculations. Okay? So, take note, we've been learning about probability in the majority of the beginning part of this course. It's important to learn about probability because when we talk about degree of freedom, here we go, probability comes into play again. We only consider samples that are governed by chance. Okay? And when we do sampling, those samples that are governed by chance or the degree of freedom is always 1 less than your number of sample. Again, if you did 30 samples, your degree of freedom will be 29. So, in the next 2 slides, we will see why we need to subtract 1 in order to get the degree of freedom. Let's look at 2 scenarios, okay, where we would most likely get into when we do sampling for research or thesis. So first, let's look at the scenario when we are lucky enough to know the population mean of the variable that we are analyzing from our samples. So here we are already given the population mean, which is 8. And we are to do 3 samplings. So that's in the first column here. So sampling 1, sampling 2, sampling 3. Okay. And on the second column will be the values of those samplings. Okay. So if I'm going to ask you a question, in our first sampling, will you be able to predict what the value will be? Naturally, the answer is no. Okay. So in this case, you wouldn't be able to predict that it's 5. Now, if we try to get the deviation between our sampling value and the population mean in the third column, we are going to end up with -3. Okay. What about in our second sampling? Will you be able to predict the value? Again, the answer is no. So you wouldn't be able to predict that it is 7. And the deviation between 7 and our population mean is -1. What about in our third and final sampling? Can we predict the value? The answer is no. Okay? It could be any. Okay. And in this case, you wouldn't be able to predict that it's actually 10. And the deviation between 10 and our population mean is +2. Okay? So, in this particular example, we were not able to predict all three of these values. Meaning to say, all three of them were free to vary. Meaning to say, when you know the population mean, there is no degree of freedom to consider. Meaning to say, you did 3 samplings, you will also have 3 that are free to vary. No degree of freedom. Only when you know the population mean. But most of the time, we wouldn't be able to get the population mean. Instead, we simply depend on our sample mean. So in this case, x bar equals 5, which is a good estimator of the population mean. Okay. Now, in this second scenario, this is where you'll most likely find yourself when you do your thesis. You wouldn't know the population mean. So, the same story, we have 3 samplings, 1, 2, and 3 on the first column. Okay? And I'm going to ask you the same questions. On the second column, when we get to know the value of our sampling, will we be able to predict what the value of the first sampling will be? The answer is no. You wouldn't be able to predict that it was 11. Okay? And the deviation between our first value and our sample mean is +6. Next, on our second value, will we be able to predict what that be? What that will be? The answer is no. You wouldn't be able to predict that it was 8. And the deviation between 8 and our sample mean is +3. Now, here's the interesting part. Will we be able to predict the final value or the value of our final sampling? If your answer is still no, then you are wrong. The answer is we can already. Take note that we don't know the population mean. Instead, we know the sample mean. And how else do you compute the sample mean? But through averaging of your values per sampling. Okay? So, since we already know the sample mean, and that this has to be, sample mean has to be 5, then we somehow already have an idea what this should be. Okay? So, take note, this is 11. This is 8. Okay? 11 plus 8 is 19. What do you need to add to 19 so that when you divide the final sum by 3, the answer is 5? What number do you divide by 3 so that the answer is 5? That's 15 divided by 3, 5. So how do you make 19 into 15? Therefore, our final value here should be a negative number. In this case, a -4. Because 19 plus -4 is 15. And 15 divided by 3 is your sample mean 5. Okay? And take note, the deviation between your final value -4 and your sample mean is -9. And we also know by rule that the sum of all deviations should be 0. Okay? We could have predicted -4 by just looking at this column. 6 plus 3 is 9. What do we need to add since we only have 1 left so that the final deviation is 0? And that's -9. Okay? And what number would it be that has a difference from +5? So that if we add that difference with 6 plus 3, the answer will be 0. That number is -4. Take note, when you don't know the population mean and you only base your calculations on sample mean, you only have, out of your 3 samplings, you only have 1, 2 that are free to vary. The last one, in this case, -4, is predictable. Therefore, if n is your 3, the number of values that are free to vary is n minus 1 or 2, and that's your degree of freedom.